Welcome to Unit 10. Find from the first principles the gradient function of the equation y equals to s raised to power 3 plus s raised to power 2 minus 1, where s is equal to minus 1. Second question, y equals to a over x, where a is a real constant. So let's take the first equation. 1. Y is equals to x raised to power 3 plus x raised to power 2 minus 1. Gradient function. Is equal to Q arrow all over PR. Then I can say that x plus h raised to power 3 plus x plus h raised to power 2 minus 1. Minus x raised to power 3 plus x raised to power 2 minus 1 all over h. So let's try and do the expansion. You are used to the expansion now, so I'm not going to go into that rigor. We have x raised to power 3 plus 3 s squared h plus 3 sh squared plus h raised to power 3 plus s squared plus 2sh plus h squared minus 1 minus x raised to power 3 plus x raised to power 2 minus 1 all over h. So let's try to do the expansion now. We now have x raised to power 3 plus 3x squared h plus 3x h squared plus h raised to power 3 plus x squared plus 2x h plus h squared minus 1 minus x raised to power 3 minus x raised to power 2 plus 1 all over h. So let's see how we can cancel out. 3x raised to power 3 plus x raised to minus x will go away. That means we cancel out. Then plus s squared minus s squared will cancel out. Plus 1 minus 1 will cancel out. So let's see what we have. 3s squared h plus 3x h squared plus h raised to power 3 plus 2x h plus h squared all over h. So let's try to factorize and take away h. We have h 3s squared plus 3sh plus h squared plus 2x plus h all over h. H, we cancel h. What you have is 3s squared plus 3xh plus h squared plus 2x plus h. P tends to Q, h tends to 0. Therefore, we have h squared is equal to 0. We have 3sh is equals to 0. So, our gradient function will now be equal to, this one is equal to 0, this one equals to 0, this one equals to 0. So you have 3s squared plus 2x. This is your gradient function for the equation y equals to x raised to power 3 plus x raised to power 2 minus 1. So, where x is equals to 1, where s is equals to minus 1 from the equation where s is equals to minus 1. So let's substitute into the equation. It now becomes y is equal to 3 into minus 1 all squared plus 2 into minus 1. So, it's equal to, when you square minus 1, you have 1. So it becomes 3.1 minus 2. So it's equal to 3 minus 2 equals to 1. So that is our answer, y equals to 1, when y is equal to s raised to power 3 plus s raised to power 2 minus 1. Let us see if we can handle the second question. Solution to the second equation, y equals to a all over x. Gradient function is now equal to q arrow all over p arrow is equal to a all over s plus h minus a all over x. So, all over h. So we have equal to a all over s plus h minus a all over s all over h. So let's deal with the first one. A all over s plus h minus a all over x. X into s plus plus h. X plus h will go, you have what? X. So you have ax minus. This will go, x will go with x. Then you have a into x plus h. So let's expand. You are going to have ax minus ax minus ah all over s squared plus xh. So let's try and cancel. This one will cancel this. So you are going to have minus h over x squared plus xh over h all over 1. The same thing as minus ah over x squared plus xh times 1 over h. So we are still going to expand this one. The same thing. Let's come here. I'm going to have minus ah into h into s squared plus xh. Now become minus ah all over s squared h plus sh squared. So let's bring out h. It's equal to h into minus a over h into what? S squared plus sh. So h into minus a all over h into s squared plus sh. H will cancel h. I'm going to have minus a over x squared plus xh. Now, as p tends to q, h tends to 0. Therefore, sh is equals to 0. So this is equals to 0. What you have? Minus a all over x squared. So that is the gradient function. Is equal to minus a all over x squared. So the gradient function for y equals to a all over x is minus a all over x squared. Thank you. We will be having the yd's in unit 11. Bye.